Hello, thank you for watching this video. And in this video, we're going to be talking about the gradient of a straight line, also the equation of a straight line. When we're talking about gradient, we're talking about the steepness of something. In this illustration, you can see that we are familiar with gradients in terms of climbing up a hill or riding a bicycle up a hill or even just like climbing stairs. So the steepness is how high this line is compared to how wide it spreads. So you can tell here that this line is steeper than the second line. So that is gradient, the steepness of something. As you saw in the previous example, to be able to measure this steepness, we get to measure how high the height is compared to its like length or width in terms of spreading along the horizontal axis. So this can be put in mathematical terms to say y2 minus y1, which is this height, over x2 minus x1, which is this length here at the bottom. So that's how we get to measure the steepness. So here you can see again we had 100 rising, 100 on the run, then we had just 50 rising, but 100 on the run. So this is why this line is actually steeper. This line has got a steeper gradient. Yeah, so it's y2 minus y1 over x2 minus y1. That's how we get to measure. So yeah, in this case, you can see that our y2 minus y1 is this height here, which is 9. And if we put that 9 over the run, which is our 8, so that would be 9 over 8. So the gradient for this second line, the black line, is 9 over 8. And if we come here to the last picture for this pink line, you can see we get to use the same method. So y2 minus y1. So our y is this is the minus 1 and the minus 5. So our y2 is minus 5, our y1 is minus 1. So minus 5 minus minus 1. That's how we get the 4, the minus 4. Then to measure the run, so what the minus 4 is coming here. So minus 1, minus 2, minus 3, minus 4. This is just the height again. And then to measure this length here from this point to this point, we're going to measure the horizontal length, which is this. So we're going to do x2 minus x1, and that is 2 minus minus 4, we get a 6. So we actually get to see that the gradient here is minus 4 over 6, which is also equal to minus 2/3. So the gradient of the pink line is minus 2/3. Now that we know how to find the gradient of a straight line, we can be able to derive the line or the equation of a straight line just from knowing the gradient and knowing any point on the graph. So yeah, we are told that, oh, in general, the equation of a straight line is equal to y is equal to mx plus c. So the equation of a straight line is y is equal to mx plus c, and the m is the gradient, then the c is the y-intercept. The y-intercept is this is the y-axis, and the y-intercept is the point on the line that touches, or is the point on this scale which is crossed by the line. So you can see that the line here is crossing at this point, which is minus 3.5 or minus 3.5, and that is the y-intercept. So all you have to do is just to look along this line of the y-axis. Whenever the line crosses that line, that is the y-intercept. So if the line was going that way, then maybe if the line was crossing the y-axis at this point, which is minus 1, the y-intercept would have been minus 1, but in this case it's minus 3.5. Yeah, so given the gradient and the y-intercept, you can write down the formula of a line. And in the previous slide, we saw that the gradient for this pink line was minus 2 over 3. So we can write minus 2 over 3x minus 3.5. So the plus c was actually a minus 3.5. So that's why we have minus 3.5. So our line here is y is equal to minus 2/3 x minus 3.5. This is the equation of this line, and we're able to derive it from knowing the m, which is the gradient, and knowing the c, which is the y-intercept. Let us look at a typical question that is asked when dealing with gradients. So here we're given the question, Find the equation of a line that passes through the points 4, 2, and 1, 6. So here the equation of a line in general is just y is equal to mx plus c. But we have to put a number instead of m and instead of c. So what we are trying to look for first is to look for the m. So this is the gradient. And we are given that the formula of the gradient is y2 minus y1 over x2 minus x1, as we saw earlier. So this is the formula, or this is the equation that we're using. So using that equation, we are able to get our gradient by putting by putting 6, 2 as y2 minus y1, and then 1 for as x2 minus x1. So yeah, we were able to find our m, which is minus 4 over 3. Now that we have our m, we're still looking for our c. Or it's easy to find our c now that we have an m, and we can also check. We can also get any point. You can either get 4, 2 or get 1, 6. In this case, we just use 4, 2. So if we look at the point 4, 2, what it means that the line is going to pass through this point 4, 2. So that means if x is 4 in the equation of the line, then the y is going to be 2. So we'll take 4, 2 into our equation. So we'll make, we just substitute y as 2 and x as 4. And now we know that m is minus 4 over 3. So that means we have everything else. We have the y, we have the m, we have the x. We just don't have the c. So here we'll just calculate for the c by making c the subject of formula. So that's how we found the c. So after finding the c, we can say that we come back to our general formula, which is y is equal to mx plus c. What was our m? Our m was our gradient. What was our c? Our c is the y-intercept in general. However, in this case, we don't have a graph to see which one's the y-intercept, like to see where is the line crossing the y. But what we have are 2 points, and we can take either of these points to calculate the c, because the points give us an x and a y, which we can substitute in this formula. So if we put that y and the x coming from a point, we already have an m. What is only left is the c to calculate. And so we found that the c is 7 and 1/3 here. So our equation of this line, which passes through 4, 2, and 1, 6, is y is equal to minus 4 over 3, which is the gradient, plus 7 and 1/3, which is the y-intercept. That is how you find the equation of a straight line when you're given 2 points on a graph, or when you're given 2 points.